Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of relations and functions, and now we are solving the examples of functions. We have already solved 7 problems, now we are in the 8th question. Look at this question. We are again discussing about the domain of the real valued functions, real functions. So f of x is equal to modulus of x plus 3 divided by x plus 3 is, alright. So you can write the modulus function and separate them as 2 branches. Okay, so you can do this, but not necessary for this particular question, alright. So similarly you can write x plus 3. Okay, so minus of x plus 3 if x plus 3 is less than 0, and so on. You can do that, and then you can divide and simplify the function, and then you can understand the domain easily. But there is a very simple thing here, that is, whenever you have a rational function, don't worry about modulus at all, because that is in the numerator. So numerator can take any values here, any value. It can be positives, negatives, 0, okay, any real number. But the problem is with the denominator. Denominator should not be 0. That's the rule of rational function, correct? Okay, so if you have anything by the expression in the denominator, the expression should not be 0. So denominator should not be 0 here. That means x plus 3 should not be 0. Then only f of x will be defined. Right. Then what do you mean by x? See, x should not be minus 3. So you can have any value of x except minus 3. So that means you can have any real number in place of x, the input values, alright. The input values are the domain values. So you can put any value, any real number except minus 3. So from the set of real numbers you have to subtract the set containing the element minus 3. So therefore the domain is R minus the set containing that element, alright. So therefore the option B is the right answer for this particular questions. The whole thing here is the denominator in the rational function. Denominator shouldn't be 0. Only that you have to keep in your mind. Let's move on to the question number 9. Look at the question number 9. Again it is domain, right? Okay, so you have to find the domain of f of x. Now the situation is slightly different. We have done a problem regarding this already. So 1 by square root of modulus of x minus x. Now here there are 2 things. One is the rational function. Denominator should not be 0. The second thing is you have something within the square root. So whatever you have within the square root should not be negative, correct? So there are 2 things here. One thing is square root of the denominator, I am saying. So that means this quantity also shouldn't be 0, and then whatever you have within the square root should not be negative. That means it should be positive or 0, greater than or equal to 0. Now it cannot be equal to 0, and it should be greater than or equal to 0. So it cannot be equal to 0 means it should be strictly greater than only. So combining these 2 we get should be greater than 0. That means mod x should be greater than x. In other words, x should be less than mod x. Now when I explain the modulus function, I gave this property, the first property. If you remember, a is less than mod x, then less than a, I am sorry, then a is less than 0, correct. So when it will be equal, it will be equal, yes, a will be equal if a is positive. Okay, I'll explain this. Understand, you take x is equal to minus 2, then what will happen here? Minus 2 is less than mod minus 2, which is 2. Is this true? Minus 2 is less than 2? Yes, obviously. So if you want to satisfy this inequality, what should be the value of x here? The value of x must be minus 2. The value of x must be minus 2. So that's the only thing you can have. You cannot have the positives. So the meaning of this, see what will happen if you have positives. Let's clarify that also. So if you put 3 here, then 3, is it less than mod 3? Mod 3 is 3 itself. So this is equal actually, correct? Okay, so if they are positive, it will be equal, it won't be less than. So when it will be less than? Only if x is negative. That means your domain is negative values, less than 0. So minus infinity till 0. And do you think 0 is included? No, you cannot include 0. No, you have to exclude that. Therefore, open interval, you cannot put 0, because if you put 0, mod 0 is 0, this is also 0, that will be equal, it won't be less than. So it should be strictly negative. So from minus infinity till 0 you can go, from minus infinity to 0. That's the first option. Well, this is about 3 things here. One thing is the rational function, second thing is whatever is within the square root must be greater than or equal to 0, and the third thing is the knowledge of modulus function. Okay, so combining these 3, you have to analyze the question and then find the right answer. Well, we have done it. Now let's move on to the question number 10. The domain of the real valued function, see here you have the combination of 2 functions, okay, sum of 2 functions. Now understand the concept first. If domain of f of x is d1 and g of x is d2, then what is the domain of f of x plus g of x? So that will be d1 intersection d2. Keep this rule in your mind, the 4th rule. When I explained the rules of finding the domain, I explained this, okay, the 4th point. So f of x plus g of x. Yes, how do you find the domain? d1 intersection d2. So let's find the domain of f of x. I mean this function, this is f of x. So you can take this as g of x and h of x. So let's find the domains separately and then we'll find the common region. Well, so let's begin. Now first let me write g of x as square root of 5 minus 4x minus x square, and then h of x, that is x square and log x plus 4. Well, now see, x square does not have any role to play here. You can put any value in place of x square, but there is a condition, okay, for these values, because log takes only the values that are positive. It does not take 0, does not take negative values. So those are the that is the thing you have to remember. And if you have something within the square root, that should be greater than or equal to 0. It can be 0 also within the square root. It cannot be negative. It cannot be negative. Here 0 is also not allowed. So here 5 minus 4x minus x square should be greater than or equal to 0. And what about here x plus 4 should be positive. It cannot be equal to 0 also, because log does not take negative and 0. Okay. Now this is simple. So x must be greater than minus 4. So what is the domain Okay, so domain of h of x is greater than minus 4. So you have minus 4, 0 and so on. So greater than minus 4. So minus 4 to infinity. And minus 4, is it included? No, strictly greater. So open interval, and infinity is never included because infinity is not a definite number. You cannot fix it to a definite number. Okay, so if you put 1 crore there, then 1 crore and 1 becomes the infinity. 1 crore and 2 is there, 1 crore and 3 is there, 10 crore is there, 100 crore is there. It's never ending. You cannot put a full stop there. You cannot include any number there. Infinity is not a definite number. It is just the concept that there is the highest number possible. Well, now let's solve this. See, this is quadratic equation but with the negative here. So take the negative sign outside. So this becomes plus and minus 5. Now this is greater than or equal to 0. Now if I multiply with minus 1, then inequality reverses, correct? So inequality changes y. Understand? If you have minus 2 less than 4. Okay. Now if you multiply by plus 1, minus 2 is less than 4, correct? Okay. So if you multiply by minus 1, then what will happen? This will be minus 1 into minus 2 and this will be minus 1 into 4. So this is 2 and this is minus 4. Now what is the sign you will put? Which is greater? 2 is greater, right? Minus 4 is less. So this is greater. Inequality reverses. Inequality changes if you multiply by a negative number. Here what are you doing? Multiplying by minus 1. Okay, minus 1. Minus 1 into 0 is 0 itself, but still this becomes positive, right? So negative becomes positive. So change the inequality. That's the rule of inequality. Then let us factorize this now. See, you should get 4x. So minus 5x minus 1. 5x minus 1x can be put here. So that is 5x minus x minus 5, right? Now this is right. Take x common. So this is x plus 5 and minus 1 here. This is also x plus 5 and then x plus 5, x minus 1 less than or equal to 0. So what are the different values of x here? So either x plus 5 must be less than or equal to 0 or this must be less than or equal to 0. Understand? We are saying this is negative. When this product will be negative? If both are negative, then it will be positive, correct? Minus into minus. So what is the possibility that we have? Either this is negative and that's positive, or this is positive and that's negative. If both are positive also, that won't be negative, right? So either x plus 5 is greater than or equal to 0 or x minus 1 is less than or equal to 0. So that's the one possibility. Or you have x plus 5 positive and x minus y, this is positive again, I am sorry. So this is positive, here you will take negative and here positive. Understand? The first quantity is positive and the second is negative. That's one possibility. Whole product will be negative, correct? Plus into minus. Or the first quantity is negative, second is positive, minus into plus is also less than 0, negative. Well, so these are the two things that are included there. Now let us analyze with the real line. See, what is the meaning of this? The meaning of this is x is greater than or equal to minus 5 and x is less than or equal to 1, or x is less than or equal to minus 5 and x is greater than or equal to 1. That's the meaning of it. I have just taken this 5 to the other side, minus 1 to the other side, correct? Alright. Now for this first one, what you get is minus 5 greater than. So you got minus 5 somewhere around here, rough. Okay, so it should be greater than that, and it should be less than or equal to 1. Okay, it matches perfectly. So this can be written as x is greater than or equal to minus 5 and less than or equal to 1, or this also can be written as minus 5 comma 1 closed interval. Right. Now then you got this. Now what about this? X is less than or equal to minus 5 and x is greater than or equal to 1. That is also there. So do you have any region that is common there? No, you don't have any region common there, correct? So either this or that. You can write it, okay, union of both. You can write union of both, but it should be both the regions. Okay, both should satisfy. Now which value of x will satisfy this? You tell me. Which value will satisfy? Which value is both less than minus 5 and greater than 1? Do you get any value? You don't get any value which satisfies both. See, this is and both must satisfy. Okay, so both must satisfy, both does not satisfy for any value of x, therefore we don't get any region here. So let's continue. So what is the domain? Of g of x? D1. So domain of g of x is this, minus 5 to 1, and D2 is minus 4 to infinity. Now let us combine both. And get the common region. Okay, and let's decide which option is correct. So let me draw the real line. You have minus 5 and 1. So this is one region, and the next region that you have is minus 4. This is open interval, and till positive infinity. Okay, till positive infinity. So one region is this, and the second region is this. Now what is the common region? The common region is what point is this? This is 1. Right. Okay, the common region is between minus 4 open and 1 closed. So minus 4 open and 1 closed is the common region, because the domain of f of x is nothing but D1 intersection D2. So we need to find the common region. Okay, not the union of both. It's not union, it's intersection of both. Okay, so we have to find the common region. Okay, intersection of these two intervals, and that is option C. So I hope you understood. Okay, so we have to begin here and end here. So is this common to both? No, this is only in the blue region. Okay, so we need to find the intersection of blue region as well as white region. All right, so this is white as well as blue. So that's the common region. I hope you understood this problem. Looks little complicated, but as you go along, as you practice questions like this, you will get used to it. Well, let's move on to the next question, question number 11, and that's not as complicated as this. Look at question number 11. You have got f of x there, and that is log to the base 2 of log to the base 3 and log to the base 4 x. Well, now when do you think a function with log will be defined? only if this quantity is positive. See, log takes only positive values, it does not take negatives, it does not take 0 also. Okay, it doesn't take even 0. So this quantity that you see within the log must be positive, then only f of x will be defined. So f of x is defined if log to the base 3 log to the base 4 x is positive. Now next you convert this log to exponential. Then how does this become? See, understand, if you have log to the base a, x is equal to y, then what is x? It is a to the power y, is it not? So x is nothing but, the bases are same. Okay, so that comes here and this goes that side. All right, now understand, I need to find this. See, this is in the place of x. I need to keep that separately, independently. Then what comes in the right hand side? Inequality does not change, it is the same. See, 3 is the base, and what goes as the power? 0. That's in the place of y, so that's the power. Well, now what is 3 to the power 0? 3 to the power 0, anything to the power 0 is 1. Now again use the same concept. Okay, I need this x independently because I need to find the domain here. What is the meaning of domain? The values of x, the input values, right? So x is greater than, now what is the base here? What is in the place of a? 4 is in the place of a, so 4, and y, you got 1, so that comes here. Now what is 4 to the power 1? 4 itself. So x must be greater than 4. What is the meaning of it? All right, so you got 4 and it must be greater than, so it must be greater than 4. So it is not closed, it is the open interval and till infinity. Therefore the domain is 4 till infinity. Okay, so 4 comma infinity is the right option. Well, so this was so much easy, right? So any problem with log is easy. Only the thing is you must be careful that you must remember that this must be positive. Log takes only positive values. All right, so let's continue with the next questions, and those questions are based on finding the range of a function. Now we are in the question number 12, and these questions are based on finding the range of the function. Now the first function is f of x is equal to x minus 2 divided by 2 minus x. See, these are the options that we see, and it's a very simple question. See, what we need to do is understand that 2 minus x is nothing but minus of x minus 2. If you understand that, then you got this answer. So what I am doing here, I'll just take minus common. So what happens here? This cancels. That's it. So this is minus 1. So you put any value, you are getting just minus 1 for anything. Okay, for any domain here. See, this is the domain. X values are the input values. Okay, these values are the output values, and that's the range value. So domain can be anything, input can be anything. You put 1, answer is minus 1. You put 5, answer is minus 1. You put minus 10, answer is minus 1. This is the constant function. Okay, this is the constant function. It doesn't change for any value of x. So this remains at minus 1 always. Okay, so that remains at minus 1. This is the x-axis, y-axis. So for any value of x, y is always minus 1, constant function. So what is the range? Range is minus 1, that's it. So it is the set consisting of minus 1, one single value. So set of all values of the output is minus 1. So you are not getting any real number. Okay, so you are getting only minus 1, just one value. So that was so simple, but only if you understand. Well, now let's move to the 13th question. The 13th question is finding the range of 1 plus x square divided by x square. Now what are you going to do here? See, you see x square, so take it separately, I mean split the numerator. If you split the numerator, you are going to get 1 by x square, and that is x square by x square, which is 1. So this can be written as 1 plus 1 by x square, and this is your f of x. Now we go on putting the values at x. Okay, input values. That's not the question, we need the output. Okay, so what will be this output? You put 1, what will happen here? 1 square, 1 by 1, so that will be 2. Can you put 0? No, you cannot put 0, right? You cannot put 0 and then it won't be defined, so that's not in the domain. So only the domain values you have to put. So you put minus 1. What will happen if you put minus 1? Okay, so what is a few values I will take. Minus 1 I will take first. So if you put minus 1 square is 1, 1 by 1 is 1, 1 plus 1 is 2, and then if you put f of 1, then also we are getting 2. If you put f of minus 2, so minus 2 square is 4, 1 by 4, 0 0.25. So 1.25 you are getting. And if you put 2 here, that is also same because you have square. So positives, negatives and the positives will give you the same output, right? So it goes on like that. If you put 3, that will be 1 by 9, so 0 point something, so 1 plus 1 point something. Okay, so always you will get 1 point something. And what is the least you will get? The least you will get is 1.0001 or something. Okay, you won't get 1 at all. When you will get 1? If this quantity is 0, but this quantity is never 0, correct? This quantity is never 0. You put any value here, that won't be 0 at all. That won't be 0 at all, but very close to 0. Yes, very close to 0. Yes. So your range will be the lowest possible. The lowest possible is 1, and 1 is not included. 1 point something, but 1 you will never achieve. So don't close it. 1 is not included. You won't get 1 for any value of x, right? So starting with 1 point something, 1.001 or 0.00001 or anything like that. And what is the maximum that is possible? The maximum that is possible is you get 2, correct? All right. So that is for minus 1. You will get even more than that. If this is 0.1, let us say, if this is 0.1, that will be 0.001. So 1 by 001 is 100. So 101 you are getting. You will get any 1000 crore, 10 crore, you will get anything. So you will get infinity, correct? The maximum is infinity. Therefore option C is the right choice, and 1 is not included. It is open, right? Because this is never 0. You won't achieve 1. Above 1 you will always get. Well, so that is the question number 13, and that's about range, not the domain. We are talking about the output values, not the input. Okay, so what is the input? Basically, what is the input? X square should not be 0. So r minus 0 is the domain here. Okay, anyway, that's not the question. Well, let's move to the 14th question here. Question number 14, that is also finding the range of f of x, right? Are you with me? Yes. So f of x is equal to x minus 2 divided by x minus 3. Now this is going to be really interesting, because we need to use the rules that we have learned of finding the range. So what did we learn? We have to write f of x as y and then try to express this quantity in terms of x, I mean in terms of y, right? Okay, so try to get x, x is equal to something. How do you going to achieve that? How are you going to achieve it? So by cross multiplying. So let me cross multiply. So if you cross multiply, you will get this, okay, then multiply it. So xy minus 3y, obviously now we need x, so take x on one side. So I'll take this and 3y minus 2, because that will be positive on the other side. Now take x common, so this is y minus 1, 3y minus 2. Finally, what is x? 3y minus 2 divided by y minus 1. Now, does it belong to real numbers? When this is defined, so for what values of y, x is defined? See, only for those values x is defined for which values of y? Okay, so defined if y belongs to, see, when this quantity is defined only if this is not equal to 0, correct? So x is defined if the denominator is not equal to 0, that means y is not equal to 1. So when that means you can have any real number in place of y except 1. See, if you put 1, what will happen? 1 minus 1 becomes 0. Denominator is 0 means x is not defined. Okay, so that means this quantity is not defined. So this quantity is defined only for the values of all real numbers except 1. So what you have to avoid is 1, and all the other real numbers you will get here. All the real numbers you will get here. So R minus the set containing 1 is the required range. So this is the typical method of finding the range. Please understand this. First write f of x as y, then try to express x is equal to the expression. Now understand when x is defined, for which values of y x is defined, and those values of y are the range values. See, this is the thing you can visualize. Okay, so these are the domain values, and the output values, y values, are the range. So any real number except 1, y cannot be 1. So y cannot be 1, and you can have any real number here, whereas here you can have any real number except 3 shouldn't be there, otherwise f of x is not defined. So this is the domain, so that should not be there. Well, I hope that is understood. Now let's move on to the 15th question. Once again, the 15th question is finding the range. Now this requires the knowledge of modulus function. So I'll write the modulus function for you. This is minus x if x is less than 0, and plus x if x is greater than or equal to 0. Now let me write the given modulus function as two separate branches. So how can I write it? So this is the way we can write it. This is minus of x minus 1, right? So in place of x I have x minus 1, so that's what I have written in place of x. If x is less than 0, so what is the meaning of it? X minus 1 is less than 0. In place of x I have got x minus 1. Similarly the next one, so that is x minus 1 if x minus 1 is greater than or equal to 0. Now let me take this minus 1 to the other side, and let me multiply this minus inside. So that's all I will do here. So this is 1 because minus and minus plus, and this is minus, and this will go to the other side and becomes less than 1, and here you have x minus 1 if x is greater than or equal to 1. Okay, we are talking about the range. Range is the output values. That means these values. What is the lowest value possible? When do you think this will be lowest? See, understand, you have 0, you have 1. So here greater than or equal to 1, and these values are less than. Okay, now if you put 0, what will happen? If you put 0 is less than 1, so you have to put it here, so you will get 1, correct? So f of 0 will be mod of minus 1. Mod of minus 1 is 1 itself, otherwise you put 0 here, that's understood. And what about f of minus 1? F of minus 1 is also less than 1 here, correct? So you have to put minus 1 here. Minus of minus 1 is plus 1, that will be 2, and it goes on like that, it increases. I am talking about the lowest. So where do we get the lowest values? So if you put 1, so what is f of 1? F of 1, see, equal sign is here, so put 1 here, 1 minus 1, you will get 0, right? So now the question is, do you get negatives? So try. We have put already negative here. So if you put minus 2, what will happen? If you put minus 2, that will be 3. And if you put 3, for example, the positive quantity, 3 minus 1, 2. So that will be mod of 2 is 2 itself. Okay. So do you get any value less than 0? You will never get. And you get 0, that means 0 is included, correct? And you get only the positives from 0 in the range, the output values. So here what you get is, either you will get 0 when x is 1, or whether you take negatives or positives, you are going to get the values which are more than 0. You will never get the value less than 0. So 0 and the positive values till infinity. So that is the range, and that's the first option. So this is about the modulus function. Understand the definition of the modulus function, or you can directly start with this. Know that mod is always positive. You will understand this question. So that's it for this class. Thank you very much for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.